that's me. I'm also on Twitter. As said, I work at Commercetools, and one of the things I did there is I took our platform as a service and I integrated it with basically 4 different cloud vendors. Well, Iron.io, we don't really promote this anymore, but I did this in the past. And I worked with all these serverless offerings. So basically, I also wrote tutorials saying, hey, this is how to solve a problem with AWS Lambda. Hey, this is the same problem, but this one is solved with Azure Functions. Then here's also how to solve it with Google Cloud. So I had to write the same thing over and over again. I figured out it's not a lot of fun. Maybe I can write something that makes it easier for me to write this tutorial once and then deploy it for each different cloud. So this is what I'm going to present today. Well, this experience also led me a bit to see there's a lot of pain in doing that, and this is why I became a contributor to the Cloud Events standard. So there's another talk later today on Cloud Events. I recommend you to check it out. But let's talk a bit first about Commercetools, the product, to give you a bit of context. So what we want to do is e-commerce in the cloud. So e-commerce, that's been around since forever, right? Products have been written since the 90s. You could just take an existing product, put it into a VM, deploy it in the cloud. Maybe magic things happen, and then it's suddenly cloud native, right? Nope. Unfortunately not. That will not scale, at least not down to 0. So you will always have a minimal cost of deploying a few VMs, even if it's just your development system. It's still a monolithic application. It's still ops heavy. And it's just not serverless. It doesn't fit well into the serverless ecosystem. So instead, what we do as Commercetools, we do really cloud-native e-commerce. We build it from our commerce system from scratch up. It's multi-tenant, API first, event-driven, auto-scaling, blah, 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 blah. The end is it fits perfectly into a serverless ecosystem. But there's one thing. We started doing this in 2011, 7 years ago. So that, in terms of cloud, that is centuries ago. That's not quite Stone Age. Well, it's kind of Middle Age, right? We kind of had weapons. We had fire, but we didn't have electricity. We could build some cool stuff, but it's not the skyscrapers of today. And things have changed quite a bit since then, right? So let's maybe look a bit back at 2011. So no one knew even what serverless was back then. Well, AWS, they were already the market leader. Well, who was actually number 2 in sort of public cloud? Azure? Well, that was still called Windows Azure. There was also this thing called Windows Phone at the time. And that basically didn't support Linux at all, right? So if you had any software like open source database or Elasticsearch or whatever, and you wanted to run it on Linux, no chance, no way to do it. That came later in 2012. Google Cloud, well, also existed, but it was basically App Engine and cloud storage. And the thing is, again, you couldn't deploy any software. You had to write really specific stuff for Google Cloud App Engine to make anything run there. So not really contenders for more general purpose stuff. So who was actually number 2? So both in terms of revenue with cloud services and sort of breadth of product offering, that was Rackspace Cloud. And it was actually kind of cool because they were trying to support open source and so on, and yeah. Basically, they in 2014, they themselves realized we're not keeping up with Microsoft, we're not keeping up with Google, and especially not with Amazon. We're pivoting our business. Good for Rackspace, bad for us because we were on Rackspace Cloud. So we realized in 2014, okay, that's not going to work. We have to get out of Rackspace Cloud onto something else. So we tried to do that in 2015, and nope, that didn't work. In 2016, we tried really, really hard, and we made some progress. We got a lot of our messaging infrastructure over, we integrated with other clouds, but we still didn't make it. Only in 2017, so 3 years later, we actually succeeded in getting completely out of Rackspace Cloud, which means we were heavily locked in. And it's not even that Rackspace tried really hard to lock us in. It was, I would say, mostly our own fault. So today I want to share you a bit of the lessons of how your code and your application may become locked into a single cloud vendor. Another thing for us is that we don't really drive the tech choices. Our customers come to us. So for example, we provide SDKs to use with our API. And it's not really for us to decide what programming languages our customer use. So for example, there's a part of the e-commerce community that likes PHP. Okay, so we have to go and write an SDK for PHP. And it's kind of the same for us with the cloud. Our customers, they run on different clouds. And if someone comes and says, I'm on Azure, I want to use your product with Azure, then basically we can say, okay, here's the integration, or we lose that customer. I'm also keeping Iron IO on this slide because that's also, we saw like 2 years ago there was actually kind of customer demand and people were interested in this, and this is basically ebbed off, and I think most people who are on it today, at least some are looking at migrating over. So again, this is something, this lock-in, this can happen to you, and it is worth maybe preparing a bit for this event. All right, so maybe you think, okay, this guy is going to talk about multi-cloud, and he's telling you, well, running on all the clouds, that's perfect, that's paradise. No, it's not. Actually, it's a pain. So one thing is that you really limit your tech choices on what you can run. But also in day-to-day business, it's like multitasking hell. So for example, AWS, Azure, and Google Cloud, they all have a region in London, but they all call it differently. So one calls it EU-West-2, Google Cloud calls it Europe-West2, no dash, right? And then Azure goes completely different, UK South. So if you're in your day-to-day business on the CLI trying to go into this region, and you will definitely mix this up, you will not build up the muscle memory because it's so different from each one if you switch all the time between them. But this talk isn't really about multi-cloud, it's about avoiding vendor lock-in. So first, maybe let's try to define lock-in. Well, actually, first let's try to define lockout because maybe you're more familiar with that one. So let's say I have a file, maybe a Bitcoin wallet, and I'm trying to protect it. So I could use a 4-digit password for it, right? So you already know it's a bad idea. So how do you hack it? Well, it's kind of similar. You just enumerate all possible passwords, and you try each single one. So just 10,000 possible combinations, and one of them will work, right? Okay, bad idea. So what can I do differently? I can use a more stronger password. So let's say I use a 16-character password with all sorts of funny characters. And how to hack this one? Well, you can use exactly the same algorithm. You enumerate all possible passwords. You try each one. So the algorithm to do that has stayed exactly the same. But what has changed is now I have so many possible solutions that it doesn't really work. So in another way, it's kind of easy to pick a single lock. When I have millions of locks to pick, right, it becomes really, really hard. So what locks us out is not the single unit of work, but there is so much grunt work, so much boring work that we have to do, that it becomes much, much larger than the work we're actually able to afford. So if you wanted to hack my Bitcoin wallet and you would have to spend like 10 years to do it, it's probably not worth the effort. Maybe by this time I have spent all my Bitcoins already. Or you have to spend so much cost on it that it's not going to be worth the payoff. So this is our definition for lockout, and this is also basically the definition for lock-in. So what makes you locked in is not that the cloud vendor has thought of one single super awesome trick that totally locks you in. How they lock you in is that all over your application, like many small points you have to change when you want to migrate from one place to the other. So there's so much work you have to do that it just becomes unrealistic to migrate. All right. And the point is not only to keep this portion of the code base small. So let's say if you would say, okay, 10% of my code is locked in, I can rewrite 10%. So that's kind of okay after a couple of months, but then if your code base grows larger and larger, like after, let's say, 5 years, 10% basically means you have to spend half a year to migrate that 10% of your code base to the next. So what you really want to do is you want to kind of try to keep it constant. So the overall size of your code base keeps growing, but the part of your code base that is really specific to the cloud vendor, that should stay constant the same. And the way to do that is, well, you keep the use of proprietary APIs, so those really specific to this cloud vendor, constant. Sounds maybe easier than it is. So I want to give you a live demo of how I did this for the examples that we share with our customers. So maybe let me introduce a little bit the setup. So as I said, we're a commerce platform, so one of the natural things you want to do on a commerce platform is you want to place an order. So the front end goes, it talks to our API and says, hey, I want to place an order. And then maybe we go, okay, cool, you've done it. And then what we do is kind of similar. If you, say, upload a file to S3, then an event is being triggered. That event can be put into a message queue, and then a function is being triggered. So in our example here, a function should be triggered that detects fraud. And we're going to implement this on all 3 cloud providers. On AWS, we're going to use SNS as a message queue and a Lambda function. On Azure, we're going to use a service bus queue and an Azure function. And then on Google Cloud, we use PubSub and Google Cloud function. Then I've prepared a second example. So here we see this is an asynchronous event. So this is also typical for function as a service or serverless, that we try to build like these event-driven systems that react asynchronously to things. But sometimes you also have to react synchronously. So here we also have that as an integration into our API. So here, let's say the front end wants to place an order. And you may know if you try to ship something in a package, that package is insured, but only up to a certain amount. Right? If I would try to ship my MacBook, that would be probably more worth more than what it's insured for. So maybe I should consider buy extra insurance. So we write a small function that looks at how much is this order worth, and if it's worth too much, then I'm going to add this extra insurance. And the thing to note here is that this is then a synchronous call, because the moment the front end wants to place an item into my shopping cart, this is exactly the moment that the shipping cost should reflect the added insurance. The problem here is that if my function fails to respond in time or does something other crazy stuff, then my whole platform will be down. My whole online shop will be down because it cannot perform. So that's bad. So this is one of the reasons why we tell our customers, you should consider using a function as a service. It scales up. If your overall platform has to scale up because, I don't know, it's Black Friday, it has high uptime, right? All the good things. The only thing is that you have to consider cold starts. Okay, and that thing we're also going to do on all the 3 clouds. Okay, so let's jump right in. What I want to do is I want to show you this actually in the UIs of all 3 cloud platforms, because I figured if I show you this in my code editor, it would kind of not be fun. So first of all, let's start with Google Cloud. So here I prepared those 2 functions. We see one is triggered by HTTP, and the other one we're going to look at first is triggered by a topic. Remember the name, we will see it again later. So let's jump in. This is not so interesting, but here is the code. So this index file, that basically contains my business code. So up here, I have, well, a simple function that just logs out whether this order is now fraud or not, basically. That's simple. You may notice here that I'm not using console log, so we'll get back to this in a minute. And then I have my main function, so this gets 3 parameters. One is the event that is being sent from the commerce platform. This is actually a JSON. Then I get an object response that I can use then to do something, and then my logger. So what I do is I look at the event, get out my order, get out my street name. So usually fraud detection is like a hugely complex thing. You do machine learning, blah, blah, but here we're going to do a simple thing. We're just looking, does it include a PO box? If yes, that kind of seems fishy. So then we want to say, okay, this looks like fraud. Please review it manually. In all other cases, we'll just pass it on. So, and since this is an event-driven system, what we want to do in the end, if we've done that, we want to say, okay, we've processed that event. So basically, we'll tell the message queue in the back, this event has been processed, you can delete it. Or maybe there's an error. So in this case, we want to tell the message queue, oops, something went wrong. you may want to retry this, or if you've already retried it, maybe you want to place it in the dead letter queue. Okay, fair enough. So how does this actually now work on Google Cloud? So here you see I import an adapter that's specific to Google Cloud. So let's look at this file. So here, first of all, we see the function that is being called when an error happens. This is kind of similar. There's a callback from Google, and we call it with the error. Or maybe we were successful, then we also use the same callback function, and we say, OK, everything is fine, the event has been processed. Then I'm creating this helper object. You may remember that this is being this one we used here. So now I can do this event processed or event processing failed. This is all it does. All right, now here's the more fun stuff. This is now the function that Google Cloud will actually call me with. So Google Cloud will give me an event and a callback. Now what I want to do, again, I want to get the event, but only the business-specific event out of this. So for PubSub, they give me a data object, but that data object is actually a base 64 encoded string. So what I have to do is first take the base 64 encoded, decode it, and then I know it's JSON, so I can parse it, so I get my real event. And then I also construct this logger object. It's not so interesting right now. That's just a wraparound console. Again, I will get back to this in a minute. And then I will create this free object and send this on to Google Cloud. OK, that's probably not so intuitive right now. Let's look at Azure, and you will kind of understand why this hopefully makes some sense. OK. This is also a nice shootout against which UI is quicker on which cloud provider. I don't think Azure will win this one. Here we are. OK, so can I? It doesn't really work with the screen resolution. OK. OK, so this time we see I'm getting another adapter here, but the main business logic hasn't really changed. That's all the same code. So now I need to switch to my file, which will be this one. OK. So here again, I recreate the same existing functions, but this time specifically for Azure. Not getting directly a callback function, but I'm getting a context function, and on that I can call something called done, basically the same as the callback function we got from Google, but it's wrapped into this context. So here I can give my error, I can say everything is fine, I can wrap it the same way. One nice thing about Azure and the service bus is that I directly get a JSON object. So we saw that for the PubSub case, we had to do some base 64 encoding. All this is gone for Azure. I can just take this object, pass it onto my function, everything is fine. But actually here, the reason that I have to use a logger and not console log is Azure. Because in Azure, I cannot use console log. Well, I can use it, but they do some optimization in the background, which means there may be multiple functions running in one environment, so they cannot really trace a console log to the particular function you do, so it ends up sort of in a global log pool and you don't really know what's up. So what you should do according to Azure is you should use context log. So this is why I have to create these helper object. So this is the thing in Azure. Finally, AWS, I guess this is what everyone is most comfortable with here. So here again, we require a different adapter. The rest of the function is the same. So the first part looks kind of similar to what it looked like on Google Cloud. So I get this callback, and I can supply either an error or basically null to say it's fine. Then to get my event, I have to parse this out. So it's kind of, the parse is kind of the most difficult from all the free cloud providers. I have to go, there could probably be different records, and then I have to say, okay, this is from SNS, and then I finally get the message. Okay, and then this is just a string, and then I have to JSON parse it. So now one fun fact here that I want to call out is that on Google Cloud, the first thing that I got was an event, and then I got a callback. On Azure, I first got a context, and then I got the event. So turnaround for reasons I don't really understand, just to confuse us probably. And then on Lambda, which was kind of the first one that invented this thing, well, they got three things. They got event, context, and callback. So everyone kind of made sure they have their unique choice of API. Okay, so far so good. That's the theory. Let's see if that actually works in practice. So I got Postman here. This we'll call the Commercetools API. I don't want to dive too deep into it, but we have like subscriptions. That means we put a message into a message queue that you have configured. And in my project, I now have pre-configured. This is Google Cloud Pops Up. You may remember this test topic name. So this will put, for any order I place, an order created message into this queue. Then we have the same for SNS and the same for Azure Service Bus. Fair enough. So let's go in and try to create a card. So here, well, it's not so interesting maybe. Here I create a card in currency euro, I add some line items, and I put in my address. Let's send this one. So nothing should happen yet because I just create a card. I didn't order it yet. And here I should order it. And I guess this worked. Perfect. So now let's look at the log output of each cloud provider. Let's go to monitoring. And we should see, maybe not, that my function has been invoked. Well, let's just go straight to the logs. And we see 1203, that's now. And we don't see, unfortunately, an icon. Okay, like this. Okay, here it says set status passed. So this one worked. We know we created an order that didn't look fishy. So the one that usually doesn't work is Azure, but it worked. Here we also get the same log output. And then finally on Google Cloud, let me go to the, here, the logs. We should also see that we got a passed. Okay, so to believe me that I'm not just faking stuff, I will try to add a PO box, create a card with that one, create an order, and then we'll have to wait a bit and hopefully see that a new one at some point in time ends up here. Okay, maybe not here. Let's try here. Okay, Amazon got at least the start, and now we see, okay, this one should end up in manual review. Same on Azure. And finally, also, same one on Google Cloud. So what we've seen here is basically you have a sort of business logic abstracted away above the particularities of each, or the proprietary APIs of each function as a service provided by the three different vendors. So this is the event-driven asynchronous use case. So let's go back and check out another example quickly for the for a HTTP or synchronous call. So it's kind of similar. I will not dive too much into details on this one. But basically what I want to do here, again, this is adding an insurance. So I have to check, is there something in my cart that is particularly expensive, maybe more than $500? Then I want to add extra insurance to it. And I also then I want to check, does my cart already have insurance? And then if I have to add it, here I have a different response object actually. Then I will call accept and say, yeah, please add something. Or I will say, hey, please remove this thing. Or in all other cases, I will just say, don't do anything. So for Google Cloud Functions, the way we've implemented this is that this is an HTTP trigger. So we can reuse HTTP for it. So in most cases, or in the cases we saw in this API, is that we always accept. So we would give in 200 status code, standard HTTP stuff. Maybe we would see, okay, this customer is trying to order items worth, I don't know, $1 million. That's not something that we can buy insurance for. So then we would say, okay, no, this is a 400 error. You cannot order a card this large. So these are the two different possibilities here. And then we wrap this thing up. Again, I have to take my request body and map this down. Well, let me skip Azure and then go straight to the Lambda function for this one. Okay. So here for Lambda, it's a bit different. So on Google Cloud and on Azure, I can directly trigger a function via HTTP. If I want to trigger a Lambda function via HTTP, I have to put the API gateway in front. But for this use case, for a platform, that's kind of useless. I don't really need this extra hop in between. So what we did is we directly call the proprietary API of the Lambda function. What that then means I cannot set like the status code of HTTP. So what I do instead is I have to send a response type. So the JSON that I have to return is a bit different. Again, what is also different is the way that I get things. Okay, let's maybe skip that part to not run out of time. All right, and then, okay, we already kind of run through this example, but in the response that we see, I actually have one in there. We should see that for this particular card, my mandatory insurance has been added. Okay. So to sum up my live demo, we saw like that the functions from AWS, Azure, and Google Cloud, they share the same fundamental concepts. They can respond to synchronous events, usually HTTP requests, and they can respond to asynchronous events, usually triggered by a message queue. However, the APIs for this are quite different. But if we take a bit of care, we can write a unified API ourselves and write adapters for each function as a service. What I've shown you is that I tried to write an API that's really specific for the business case at hand, which makes sense for the kind of functions that I want to write. But you could also try to take a more general approach and maybe make a more focused on HTTP level, for example, a standardized API like Express.js. So getting back to our definition of lock-in. So we know that if the grunt work becomes so large, at some point we're not being realistically able to migrate, and this is the point in time when we are being locked in. So we talked about function as a service. We didn't really talk about programming languages. I just choose Node. I don't think that's like, as with many other cases, it's not necessarily that the cloud vendors like mentally try really hard to lock you in. So some think it's nice to provide multiple programming languages, but if you choose one that no one else implements, then you have locked yourself sort of in. We talked a bit about message queues, or at least the part where a function consumes a message. And you can sort of believe me that it's also similarly easy if a function publishes a message. Well, between these two, there can actually be other stuff. Pops up functionality where you message infrastructure routes events. So actually there are some differences. I'm going to talk a bit about this in a minute. And that's not everything that you would necessarily use to write an application, right? There are like many, many more things that you need to build a full-blown application. So I cannot talk about all of this in detail. But what I'd like to do is I challenge you to ask yourself, can I even write an adapter in theory? So the first thing you should do is ask yourself, is this sort of the same concept? So if I draw this product on a whiteboard, if I use it this way, is this kind of the same thing? Turns out that for the message infrastructure, I have like a couple of different concepts. So one is this more a pub/sub one-to-end message queue, like SNS, or is this more one-to-one message queue? So the consumer already knows who the publisher will be. In the one-to-end case, sort of the producer just publishes a message, and there could be one consumer, there could be 10. It doesn't really know, it doesn't really care. So there is quite a fundamental difference. Related to that, there is message filtering. So maybe as a producer, I produce a lot of order messages. but maybe my consumers are only interested in those order events related to payment or in those related to shipping. So here what some tools allow me to is like have sort of an event type, for example, or other message attributes and filter by them. Again, if I use that heavily, I may have problems migrating later. And then the last fun feature is ordering. So again, a few message queues support this. So you can see if you want to pick one product that you will be able to migrate on into a different cloud, you have to take some care. And then there's sort of the feature set. So this is not really something that you would realize on a whiteboard, but this can also be quite nasty. So message size. Google Pub/Subs actually supports really, really large messages. Like you could think 60 megabytes. I could put images into a message. That's kind of crazy, but I could. But then if you look at Event Grid from Azure, that only supports 64 kilobytes, and I'm kind of thinking, okay, I probably have JSON files that are larger than this. So again, you also have to keep up these kind of tripping stones in mind. So more generally, I can probably write an adapter if my product is conceptually simple, and if the feature set is similar across different products from different cloud vendors, or if I limit myself to the common feature set. So examples beyond the function as a service are blob storage and key value stores. It's probably not a good idea to attempt to write an adapter if my product is conceptually complex or if it has a lot of features that I want to use. And also products that are kind of new and innovative and where cloud providers try to differentiate, I'll probably have a hard time finding a comparable product on a different cloud. Examples for this are API gateways, the function orchestration like durable functions or step functions, and also a lot of the AI and machine learning products. So my advice here is, if you can, pick products that are generally available. So for example, all cloud vendors, they offer MySQL and Postgres. So that's just a safe choice. Think about it. Same thing, but offered by like third parties, often the open source vendors themselves are, for example, MongoDB offers Mongo hosted on all three big clouds. Elastic, the company behind Elasticsearch, also offers their stuff on AWS and Google Cloud. And then you can also choose API-first products that are not affiliated with a cloud vendor. So you can switch to cloud vendor, but keep using them like Auth0 or Twilio. Right, but the thing is, you can then like move from one vendor to the next, where you move a smaller part. Like the problem with AWS is it's basically all across everything, and then you have to migrate everything at once. That's much harder than if you logged into 4, 5, 6 different vendors, and then you can move parts of these. So it's kind of unlikely that you have 5 different vendors and you remove all of them at the same time. And the other thing that I think is good, again, I said I contribute to the Cloud Event Standard, is that you can support standards. So one of the reasons why we can actually write an adapter for function as a services is that HTTP is a standard. If you think about it, it's really complex what is all going on. Like I have this status code, like I can do error handling. There are like a million ways you could think about how to do error handling. Well, we're kind of forcing the function as a service by having HTTP as a standard. They have to follow the HTTP status code, same with headers, same with the body. SQL is also a standard that is supported in many of the new database products. So again, there's another talk on cloud events, so I won't go into this, but this is basically for all the messaging infrastructure that you have between your functions. I think this is what I just talked about. There is a lot of different stuff going on there, so I hope with a standard in between those that we can also have a better way to port one application with more functionality in between functions to the next. So to come to the conclusion of my talk. So I kind of started talking about full vendor lock-in. I talked a little bit of multi-cloud, and then there's somewhat a fuzzy zone in between. So if you think about multi-cloud, you have a high ongoing effort to always maintain that system, to be running at all clouds at the same time. So many of you probably think, that's not a good idea. But then if you look at full vendor lock-in, you have a huge one-time effort if you try to migrate from one vendor to the next, if you're not being careful. Sometimes this can be worth it. So maybe you realize my vendor has this super awesome machine learning API. If I use that, I will be 10, 20 times quicker writing my product on this vendor. So in these cases, it's totally fine to lock yourself in. And you can say, OK, if I have to migrate, then I will just throw this away and completely rewrite it. Well, that's OK. I saved so much money with it. But in many cases, that's actually not what happens. We don't get so much value out of these products. So what I challenge you to do is maybe try to move from this full vendor lock-in and try to choose products where you are not running multi-cloud, or you're in a good position to actually be able to take what you've written, spend 2 weeks, 3 weeks, 4 weeks, migrate it over, and then be able to run on a different cloud. So you're truly locked in if the work to migrate becomes unaffordable. So some work is always to be expected. You cannot just and it goes from AWS to Azure, that will never work. There's always effort you have to put in. But the goal is to keep this effort contained, relatively small. We also saw that function as a services, at least if you stick to the common feature set, they share the same underlying concepts. So it's possible to write a function, some business code, that runs on AWS, Azure, and Google Cloud quite easily. But actually, the products beside the function as a service, they are the ones you should be more worried about. They are the ones that are likely to lock you in. So what we can do here, we can use open source products, and we can try to invest in standardization and standardized products. Thank you. And Commercetools is hiring. Also, if you have any cool pictures, I saw some of you take it, please tweet them or tweet any questions. I will also share the slides after the talk. Thank you.